years, there have been many theories about how the brain functions. For example, philosopher René Descartes believed that the pineal gland was the seat of the soul within the human body. And it was actually this soul that generated our thoughts and guided our actions. And you might have heard of phrenologists, who believed that each brain area was devoted to a certain personality characteristic or thought or emotion, and that as these areas developed, they would grow and create a pattern of bumps on the skull, and that these bumps could be used to study the individual. So we have early theories about how the brain worked, but our early ways of studying the brain were actually quite limited. One way that scientists did this was to wait until someone died. After that, they could do an autopsy and take out the brain and study it. And this told scientists a lot. It told them about the different structures of the brain, and allowed them to take it apart and look at it from all different angles. But as good as that is, it's actually kind of limiting, because it can't actually tell us anything about how the brain might function. It can't tell us anything about how the brain might control the body, or how it might generate thoughts. In order to start answering that question, researchers had to use traditional method number 2. Waiting until something went horribly wrong. So waiting until someone has some kind of brain injury, and then studying the effect that this injury has on the individual. And one of the best examples of this is Phineas Gage. And in 1948, Gage was working for a railroad company when he suffered a terrible accident. An explosion called an iron rod, actually the rod that you can see in this picture right here, to go directly through his head. Literally going through the front of his face, his left cheek, and coming out at the top of his head. And I have a picture of his skull here, which was taken and studied after he died, and you can clearly see the exit wound at the top of the skull. And, as you have probably guessed, considering that he is seen here posing with that metal rod, Gage survived. In fact, he apparently walked away from the accident and stayed conscious despite the fact that he lost part of his brain and a lot of his blood. And while his physical recovery was pretty amazing, what he is most famous for is the effect that the accident had on his behavior and his personality. Whereas before he was a hard-working, responsible, mild-mannered, and kind man, afterwards he was violent, angry, vulgar, and unpredictable. In fact, the changes to his behavior were so profound that when a friend of his was describing him, he claimed that Gage was no longer Gage. And what scientists were able to learn from this and from similar accidents was the idea of cerebral localization, the idea that specific parts of the brain could control specific aspects of behavior and emotion and thought, even personality. And it actually always really amused me that the phrenologists, while wrong about many, many things, turned out to be somewhat right about this one. And while they basically didn't get a single thing right, and in fact you can't really learn about a person by feeling the bumps on their head, there are really brain areas that are devoted to different tasks. But even though these instances were able to teach scientists a lot about the brain, there is still a major problem with trying to study the brain through our observations of the effects of accidental damage. And that's that we don't have a lot of control over it. We don't have control over which places are damaged. And since strokes and accidents typically result in damage to multiple brain areas, it can be hard to isolate what brain area is responsible for what behavioral change. But there are some ways around this. For example, in 1861, Paul Broca, who's shown here, studied a patient who he called Patient Tan. We'll talk about why in a moment. But this patient had a very particular problem. Despite the lack of damage to his mouth or throat or lungs or vocal cords, he had lost the ability to speak. In fact, he could only say the word tan, hence the nickname. But at the same time, he didn't seem to suffer from any other kind of mental dysfunction. And when this man died, Broca discovered that he had damage to a very particular part of his left frontal lobe, the area that's shaded in red here. And following this, Broca conducted autopsies on a number of other deceased individuals who had demonstrated, among other things, the same problem with speech production. And even though the pattern of brain damage was somewhat different for all individuals, they all had one thing in common: damage to this particular brain region in the left frontal lobe. And from this, Broca was able to determine that this area of the brain must somehow be involved in speech production. And today, we even call that area of the brain Broca's area in his honor. And people who have damage to this area, who have trouble with speech production, are said to have Broca's aphasia. And the term aphasia just refers to the loss of ability to understand or express speech. So Broca's aphasia is an aphasia that's caused by damage to Broca's area. But despite the occasional success of this method, you may have noticed a slight problem with it. And that's that it requires an autopsy to be performed, meaning that they have to wait until the person dies in order to confirm what areas of the brain are actually damaged. And as it turns out, that might take a while. Sometimes people with brain injuries live a long time. And maybe, by the time the autopsy is performed, they may have sustained additional brain injuries that were unrelated to the original one, which can make it difficult to form any firm conclusions. It is also possible that the patient might outlive a curious doctor or scientist, or the patient could move away and lose touch, or maybe the family might refuse an autopsy, or refuse to give doctors access to the brain or body. So while early doctors and scientists were able to learn a fair bit about the early functioning of the brain, the lack of control that they had over the injuries, and the time span over which this research needs to take place, made these methods really limited in terms of the conclusions that they could come to.